Greetings from beautiful downtown Hatch, New Mexico, and welcome to this presentation on characteristics of linear relationships. And one of the very fundamental characteristics is something called the rate of change, and on occasion you'll hear that referred to as the slope. Previously, we looked at situations that could be represented by this word equation, where the story begins and then something happens during the story, and by the end of the story we get to some new result. As we move further into just pure mathematical equations, we can translate that word equation into this equation here. The story begins as represented by the letter B, and then something happens is represented by the letter M times a variable X, and the result is represented by the letter Y. In this equation, the letter M is always a ratio and that ratio has the value of the change in Y in the numerator divided by the change in the input value, and that's once again in the numerator. It's always this way. The y's are divided by the x's. We'll see what that looks like in just a couple of minutes. As a review, remember that the graph of a linear relationship is a straight line. It'll never curve. It'll always be a straight line for a linear relationship. If there's any curve in the graph, then it's something other than a linear relationship. We're given this graph and a table of data that represent all of the points except one of the points on the graph. What you're to do at this point is fill in the last row in the table. You can do that either by looking at the graph or by observing a pattern in this table and just reproducing that pattern in that final row. Here's the complete table, and what we're going to do now is look at something called the constant rate of change for a linear relationship. We know that this is a linear relationship because it gave us a straight line on the graph. But what do I actually mean by a constant rate of change? Whenever we're looking at a table of data, we'll draw brackets between points and determine the distance between those 2 points that we've chosen. So on the y side of this table, we start at -8 and we move up to -5. That means we added 3 between those two y coordinates. And then we move down and go from -5 to -2. Once again, we add 3 to go from -5 to -2. And you observe that between any two y points, we increase by 3 to get the next one. And then looking at the x side of the table, we go from -4 to -2. That means we added 2 to -4. As we go from -2 to 0, once again we added 2. And as we progress through the table, you'll see that the next point is acquired by adding 2 to the previous point. The point here is on both sides of this table, the values increase by the same amount all the way through. That's true on both the y side and the x side of the table. Just as a reminder, if these numbers in the table increase as we go through the table, this is an increasing function. If they were decreasing as we move through the table, that would represent a decreasing function. So here's how we calculate the rate of change. We simply take the values from the right-hand side, all of these 3's, and put that in the numerator. That is delta y, that is the change in y as we go from one point to the next. And then in the denominator, we're looking at the change in x, which is just, in this case, the increase whenever we go from one x value to the next. At this point, we can put that delta y over delta x into the equation that we had previously, which was b, and it's going to be plus mx equals y. But remember that m equaled delta y over delta x, so that would be b add delta y over delta x times x equals y. Now, since delta y over delta x, that is the rate of change, that's the slope, equals 3 over 2, and it's constant throughout that table of data, then this is a linear relationship. If for some reason, as we move through the table, whenever we calculated delta y over delta x, and it gave us a different ratio somewhere in the table, that would no longer represent a linear equation. This plus sign in the third equation on this page is an addition sign. Whenever we have an increasing function, that plus or minus that we had between b and mx, that's right here. If we have an increasing function, that simply becomes b add mx. Likewise, if we had a decreasing function, that plus or minus sign would become a subtract mx in that equation. Now here's one for you to do. Determine if this table represents a linear relationship. Use the brackets religiously, just like I did in the example, and determine if delta y over delta x is or is not a constant. If delta y over delta x is a constant, then it will be a linear relationship. If delta y over delta x changes as we go through the table, then it would be a nonlinear function. You may want to pause the video and determine what is the case. Here's a second table. Do the same thing on this one. Determine if this is a linear or non-linear relationship. You may pause the video at this time to make your calculations. And then finally, you're given a table that represents a linear relationship. And what you're to do is to calculate the rate of change. Remember that the rate of change is delta y over delta x. I highly encourage you to use the brackets. If you don't, there's a good chance that you're going to forget what you're about in this problem. Maybe pause the video and make your calculations. That wraps up this short video, and at the end of the day there's only one thing left to say, and that is that's all, folks. Thanks for watching. Thanks for learning. Stay safe. Con cuidado.